Hello, knowledge seekers! Welcome to Remedial Tutorial Academy. In this tutorial video, we're going over complex numbers. First, let's define complex numbers. Complex numbers are the set of all numbers in the form a plus bi, such that a is a real number and bi is an imaginary number. Well, real numbers are simply positive, negative, whole, or decimal numbers. Any number you can think of that exists is a real number. As we know, we can only take square roots of positive numbers. So as soon as we take a square root of a negative number, specifically the square root of -1, we get imaginary numbers. So I represents the square root of -1, and I squared is equal to -1. So we know what real numbers look like. This can be any number like 2, -5, 12.7, -30.234. These are all real numbers. Let's look at some examples of imaginary numbers. Say we have the square root of -64. Well, this is the same as the square root of -1 times 64. So we can break that up, and that gives us the square root of -1 times the square root of 64, and our number becomes 8i, where I represents the square root of -1. Let's take 3i raised to the second power, or 3i squared. Well, we can distribute our exponent and get 3 squared times I squared, which gives us 9i squared. I squared is equal to -1, so we get 9 times -1, which is -9. So some examples of complex numbers would be -2 plus 4i, where -2 is your a and 4i is your bi term. 7 minus 3i, and 12 plus 6i. Let's look at adding complex numbers. Remember, a complex number is the number in the form a plus bi. So say we're adding two complex numbers together. We have a plus bi plus c plus di. All we need to do is add the like terms. So in this case, we want to group our real numbers together and our imaginary numbers together. A and c are our real numbers and our like terms. bi and di are our imaginary numbers and our like terms. So we can rewrite this as a plus c plus bi plus di. Let's move into some examples. First, we have 3 plus 6i plus 4 minus 2i. 3 and 4 are our real numbers and our like terms, so we'll group those together. 6i and -2i are our imaginary numbers and like terms, and we'll group those together. That gives us 3 plus 4 plus 6i minus 2i. Combining those gives us 7 plus 4i. Let's take another example. We have 5 plus 2 square root -16 plus 2 plus 3 square root -9. The first thing we want to do is rewrite both of these expressions as complex numbers. We can do this by modifying our square root -16 and our square root -9. The square root of -16 is equal to the square root of -1 times the square root of 16, which is I times 4, or just 4i. The square root of -9 is equal to the square root of -1 times the square root of 9, which is I times 3, and that equals 3i. We can rewrite our expression as 5 plus 2 times 4i plus 2 plus 3 times 3i. That makes our complex numbers 5 plus 8i plus 2 plus 9i. Our like terms are 5 and 2, and 8i and 9i. So 5 plus 2 gives us 7, 8i plus 9i gives us 17i. And our final answer is 7 plus 17i. Next, let's look at subtracting complex numbers. Subtracting complex numbers is just like adding them. We're going to combine our like terms, except instead of adding our like terms, we're going to subtract our like terms. So if we have a plus bi minus c plus di, a and c are like terms, bi and di are like terms. And our solution is going to be a minus c plus bi minus di. Let's look at some examples. Let's take the example 9 minus 6i minus 12 plus 2i. 9 and 12 are like terms. Negative 6i and 2i are also like terms. So we'll group those. We have 9 minus 12 plus negative 6i minus 2i. That gives us negative 3 plus negative 8i. Let's take another example. We have 3 minus 2 times the square root of negative 18 minus 2 plus 3 times the square root of negative 8. The first thing we want to do is rewrite these expressions as complex numbers. So let's start with the square root of negative 18. Well, this is equal to the square root of negative 1 times the square root of 18. The square root of negative 1 becomes I times the square root of 9 times the square root of 2. 9 is a perfect square, so that gives us 3i square root 2. The square root of negative 8 can be written as the square root of negative 1 times the square root of 8, which is I times the square root of 4, which is a perfect square, times the square root of 2, which becomes 2i square root 2. Let's rewrite our expressions using the imaginary numbers we just found. That gives us 3 minus 6i square root 2 minus 2 plus 6i square root 2. 3 and 2 are like terms, and negative 6i square root 2 and 6i square root 2 are also like terms, for two reasons. They are both imaginary numbers, and they both have a square root 2, which means they can be combined. Subtracting our like terms gives us a final answer of 1 plus negative 12i square root 2. Now, let's look at multiplying complex numbers. To multiply complex numbers, we use the FOIL method. FOIL method is simply first, outside, inside, last. The word FOIL corresponds to which terms we are multiplying. So if we have a plus bi times c plus di, we'll multiply the first terms, which is a times c, then the outside terms, which is a times di, the inside terms, which is bi times c, and the last terms, which is bi times di. This becomes ac plus adi plus bci plus bdi squared. Keep in mind, I squared is equal to the square root of negative 1 squared, which is negative 1. Now that we know how to multiply complex numbers, multiplying numbers using the FOIL method, let's look at a couple examples. First, we have negative 8 plus 10i times 3 plus 8i. We'll multiply first, outside, inside, and last. That gives us negative 8 times 3 plus negative 8 times 8i plus 10i times 3 plus 10i times 8i. This equals negative 24 minus 64i plus 30i plus 80i squared. Remember, I squared is the same as negative 1, so 80i squared becomes negative 80. And now we can identify our like terms. Negative 24 and negative 80 are like terms, and negative 64i and 30i are like terms. Combining these gives us our final answer of negative 104 minus 34i. Let's take another example. We have 8 plus 7i times 4 plus 5i. Let's FOIL. So we multiply the first, outside, inside, and last, and we get 8 times 4 plus 8 times 5i plus 7i times 4 plus 7i times 5i. This gives us 32 plus 40i plus 28i plus 35i squared. Our I squared is equal to negative 1, so that becomes negative 35. Identify and combine our like terms, and we get negative 3 plus 68i. Finally, let's look at dividing complex numbers. A complex number division problem has the form a plus bi over c plus di. We use complex conjugates to divide complex numbers. You can find the complex conjugate by changing the sign of your complex number. We're focused on the complex number in the denominator. This is because I is equal to the square root of negative 1, and we can't have square roots in our denominator. our complex conjugate will allow us to remove any square roots from the denominator. For example, a plus bi becomes a minus bi, and vice versa. A minus bi becomes a plus bi. So when I multiply my complex number by my complex conjugate using the FOIL method, I get a squared plus b squared. Regardless if it's a plus bi and the conjugate is a minus bi, or a minus bi and the conjugate is a plus bi, my product is always a squared plus b squared, which is my new denominator for my expression, which is now valid because it is a real number. Let's look at this in action. We have negative 8 plus 6i divided by 8 minus 5i. Our complex conjugate is 8 plus 5i. We use the opposite sign of the complex number in our denominator, so we're going to multiply top and bottom of this fraction by our complex conjugate, which is 8 plus 5i. We can always multiply any fraction by the same number over itself, because 8 plus 5i over 8 plus 5i is equal to 1, so all we're doing is multiplying this expression by 1. This becomes negative 8 plus 6i times 8 plus 5i over 8 minus 5i times 8 plus 5i. When we FOIL our numerator, we get negative 64 minus 40i plus 48i plus 30i squared. Our I squared is equal to negative 1, so that becomes negative 30. Our final answer becomes negative 94 plus 8i over 89. Let's take one more example. We have 10 plus 4i over negative 4 minus 3i. Our complex conjugate is negative 4 plus 3i. The only sign we need to change is in between our real and imaginary number. So we're going to multiply our expression by negative 4 plus 3i over negative 4 plus 3i. That gives us 10 plus 4i times negative 4 plus 3i over negative 4 minus 3i times negative 4 plus 3i. Our numerator becomes negative 40 plus 30i minus 16i plus 12i squared. Over, our a is negative 4, our b is negative 3. So our denominator becomes 16 plus 9. I squared is equal to negative 1. So our final answer becomes 52 plus 14i over 25. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.